Level 1. Script Kiddie. You download your first hacking tool late at night. The interface looks complicated. You do not understand the commands yet. But the instructions online promise results if you simply run the program. You copy a command from a forum thread. The screen begins scrolling with unfamiliar text. IP addresses appear. Port numbers flash across the display. The system feels mechanical and strangely responsive. You do not understand networking protocols yet. Terms like SSH, FTP, and HTTP appear repeatedly. But the tool explains nothing. It simply scans thousands of systems searching for weaknesses. You realize most beginners start this way. Not by building tools, not by understanding code, but by using automated programs written by someone else years earlier. The forums call people like you script kiddies. But the name is not insulting there. It simply describes the stage. Someone who runs scripts without fully understanding them. You begin exploring public databases of leaked passwords. Entire lists of emails and credentials appear online. Millions of accounts collected from previous security breaches. You test a few credentials on public websites. Sometimes nothing happens. Sometimes an account opens instantly. The moment feels strangely quiet. You expected alarms, warnings, something dramatic. Instead, the system simply logs you in as if you belong there. You begin to understand something subtle. Security systems are not perfect walls. They are probabilities. And sometimes probability simply fails. Your curiosity grows quickly. You search for more tools. Password crackers, SQL injection scanners, simple phishing page generators. Yet each tool promises the same thing: access. Most of them require almost no knowledge, just a target, a command, and patience while the automation works. You begin spending hours inside forums, not just reading guides but watching conversations. People discussing vulnerabilities the way mechanics discuss engine parts. Someone explains brute force attacks. Another describes credential stuffing. These terms slowly become familiar even before you fully understand them. You test attacks on intentionally vulnerable practice websites, systems designed to be hacked, training environments used by beginners. The moment something works feels strangely satisfying. A login bypass, a test database appearing on your screen. It is not about money yet, not about crime. But it feels more like solving puzzles inside invisible systems. But slowly the environment changes. The forums where you started include other sections. Darker threads, private marketplaces. People are selling access to real systems, corporate accounts, server credentials, entire databases. You begin to notice how casually these transactions occur, like trading digital spare parts. Someone posts a message offering remote desktop access to a company network. The price is surprisingly low. You do not buy anything, but you watch the transaction unfold. That moment changes something subtle. You realize hacking is not only curiosity, it is also a market. Tools lead to access. Access leads to value. You close your laptop eventually, but the system remains in your mind. Yet you entered out of curiosity. But curiosity has now revealed a larger structure, and you are standing at the first doorway inside it. Level 2. The freelancer. You stop relying entirely on tools written by strangers. Instead of copying commands blindly, you begin reading the scripts themselves. The code is messy but understandable if you move slowly. You notice something important. Most hacking tools are not complex inventions. They are combinations of simple techniques connected together through automation. You begin modifying small sections of code, changing parameters, adjusting scanning speeds, filtering results differently. The tools behave differently now, slightly faster, slightly more precise. The moment feels small but meaningful. You are no longer only running scripts, you are beginning to shape them. You start learning reconnaissance techniques. Before attacking any system, experienced hackers collect information first. Public data, domain records, server locations. You run your first network scanner intentionally rather than randomly. The results list open ports on a specific target. Each open service represents a possible entry point. You begin researching what those services actually do. Web servers, email gateways, remote login systems. Every system exposes something to the internet, and exposure creates opportunity. Your browsing habits change. Instead of general forums, you spend time inside technical communities. People discussing vulnerabilities in precise detail. Someone describes a recently discovered web application flaw. Another shares a proof-of-concept exploit. The conversation is technical but methodical. Chance you replicate the process on a test environment. The exploit works exactly as described. For the first time, you understand the mechanism rather than simply seeing the result. A new section of the forum catches your attention. Small freelance requests posted by anonymous users. Nothing dramatic. Mostly minor tasks. Recover a forgotten account password. Test a website for vulnerabilities. Bypass a simple login restriction. The payments are small, sometimes only cryptocurrency worth a few dollars. But the work is real. You complete your first request cautiously. The task involves testing password combinations against a small website login panel. Your script finishes in minutes. One credential works. You deliver the result through encrypted messages. The client transfers payment quietly. No celebration, no acknowledgement, just a transaction. You realize something structural. In this world, hacking is not always chaotic. Often it functions like freelance technical labor. Different people specialize in different stages. Some discover vulnerabilities. Some exploit them. Others monetize the access. You start protecting your identity more carefully. You install a virtual private network. Then another layer of routing through anonymous networks. You create separate online identities for different forums, none connected to your real life. Operational security becomes routine. You stop targeting random websites. Instead, you learn how attackers choose targets deliberately. Companies with outdated software, servers running unpatched systems, websites exposing login portals without rate limiting. The process feels less like gambling and more like research. Your income remains small, but your understanding grows quickly. You notice something subtle about the people around you. Many of them do not see themselves as criminals. They see themselves as technicians operating in a market where digital access has value. Some specialize in breaking systems. Others specialize in buying and reselling that access. You remain near the bottom of that structure, a freelancer completing simple tasks. But each task teaches you something new. How networks respond, how administrators configure security, how mistakes appear in code. Slowly you begin seeing the internet differently, not as a collection of websites, but as millions of systems connected together, each exposing small weaknesses, and each weakness waiting for someone patient enough to notice it. Level 3. The Specialist. You stop accepting random freelance requests. Well, the small jobs teach useful habits, but they also waste time. Experienced operators focus on narrow skills and refine them repeatedly. You begin studying one discipline carefully. Exploitation. The practice of turning a vulnerability into reliable system access. Instead of scanning thousands of targets blindly, you examine fewer systems in greater detail. You read technical vulnerability reports. Security researchers publish them every week. Most people only skim the headlines. You study the mechanics. You recreate vulnerabilities inside isolated lab environments. Virtual machines replicating outdated servers. Controlled networks where mistakes cause no consequences. You watch how memory behaves during an exploit attempt. How software handles unexpected input, where protections fail. Sometimes the exploit works immediately, but more often, it crashes the system. Failure becomes the primary teacher. You learn debugging tools that trace program behavior step by step. The process feels slow but revealing. A system reveals its weaknesses only when observed carefully. Meanwhile, the online ecosystem changes around you. Freelance forums still exist, but larger groups operate privately. Encrypted chat channels replace public threads. Entry requires referrals. One contact invites you into a small working group. 5 people, each specializing in different roles. One focuses entirely on phishing infrastructure. Another writes malware designed to maintain persistence inside networks. Your responsibility becomes initial access. Finding the entry point. You operate differently now. Instead of selling isolated services, the group runs coordinated operations. A reconnaissance begins weeks before any intrusion. You map company networks using public data, employee emails, software used by the organization, cloud providers hosting their infrastructure. The phishing operator builds convincing login portals based on that information. The malware developer prepares payloads designed to bypass security detection. Your role is precision. You search for exploitable services exposed to the internet. Remote access portals, misconfigured servers, vulnerable web applications. Eventually, something appears. An outdated VPN gateway running software with a recently disclosed vulnerability. You test the exploit carefully. The first attempt fails. The second attempt opens a shell. A command prompt appears connected to the remote system. The moment feels strangely quiet again. Just text on a screen. But behind that screen lies an entire corporate network. You document the access and pass the information to the group. The malware operator moves next, deploying tools designed to maintain persistence. Soon the internal network becomes visible. File servers, databases, employee workstations. The operation expands methodically. You begin to understand how organized cyber operations function. Each person performs a narrow function inside a larger workflow. No one controls everything. No one needs to. Weeks later, the group sells the network access to another actor specializing in ransomware deployment. Your involvement ends at the access stage. Payment arrives automatically through cryptocurrency wallets. The amount is larger than anything you earned as a freelancer. But the financial reward feels secondary. The deeper realization is structural. You are no longer experimenting with systems. You are participating in an ecosystem where digital access flows between specialists like raw material moving through factories. Meanwhile, the outside world begins reacting to these operations. Cybersecurity firms publish incident reports. Law enforcement agencies investigate breaches. Articles appear describing attacks against corporations. Sometimes the descriptions match operations you recognize. The language is formal. Threat actors. Advanced intrusion groups. You read these reports carefully, not out of fear, but out of professional curiosity, because the reports reveal something important. The system you entered years ago is no longer invisible. It is being mapped, studied, and slowly understood by people trying to dismantle it. Level 4. The network operator. You stop focusing only on vulnerabilities. Exploits are still useful, but access itself has become a commodity. Entire markets now exist where compromised systems are traded like inventory. Instead of breaking systems personally, you begin managing infrastructure that enables others to do it. You maintain servers designed for anonymity, relay nodes, encrypted communication channels, temporary storage for stolen credentials. The technical work feels quieter now, less about discovery, but more about coordination. You begin monitoring access marketplaces where compromised networks are listed for sale. Sellers provide basic descriptions. Industry type, geographic region, privilege level inside the network. Buyers examine listings the way investors examine opportunities. A healthcare network sells for one price. A financial institution sells for another. The market operates continuously. You realize something important. Cybercrime at scale functions less like chaos and more like supply chains. One group gathers credentials. Another group sells access. A third group deploys ransomware or extracts financial data. Your role sits somewhere in the middle. You acquire access from specialists who focus only on initial breaches. You verify the quality. Sometimes the credentials are outdated. Sometimes the network has already been secured. But occasionally the access remains untouched. When it does, you package it carefully and resell it to operators who specialize in large-scale attacks. The transactions are quiet. Cryptocurrency moves between wallets. No negotiation beyond simple messages. Trust is built through reputation systems inside private markets. You begin recognizing usernames that appear repeatedly. Some individuals specialize in corporate VPN access. Others provide domain administrator credentials. Over time, the network begins to resemble a professional ecosystem. Developers produce malware tools. Infrastructure operators maintain servers. Access brokers connect buyers and sellers. Financial specialists move money through laundering networks. Each role exists independently but depends on the others. You maintain several command servers controlling small botnets. Thousands of compromised machines responding silently to instructions. Most of them belong to ordinary users. Personal computers infected through phishing emails or malicious downloads. They perform small tasks, scanning networks, relaying traffic, testing credentials. Individually, they appear insignificant. Collectively, they form infrastructure. Occasionally, you step back and observe the system objectively. The scale is larger than anything you imagined when you first ran that scanning tool years ago. Entire criminal economies now operate inside the same digital space where ordinary communication occurs. And your role has shifted again. You are no longer only a technician. You are managing pieces of an operational network that connects hundreds of unknown participants. The work becomes strategic. You decide which access is valuable enough to keep, which credentials to discard, which networks to sell quietly before anyone notices the breach. But something else changes as well. Security firms begin tracking patterns across multiple incidents. Infrastructure overlaps. Server fingerprints repeat. Investigators slowly connect operations that once appeared unrelated. The system still functions, but the environment surrounding it is becoming more aware. And awareness changes risk. Level 5. The Ghost. You notice the investigation indirectly, not through warnings or alerts, but through patterns changing inside the systems you monitor. Several access listings disappear from markets simultaneously. One broker stops responding to messages entirely. His account remains online, but inactive. Weeks pass without updates. Silence becomes its own signal. Security reports begin mentioning infrastructure similar to yours. Analysts describe command servers communicating through layered proxies. The technical description feels uncomfortably familiar. You read those reports carefully, not emotionally, observationally. Investigators are mapping behaviors rather than individuals. But behavior eventually leads to infrastructure. Infrastructure eventually leads to people. A small detail catches your attention. One server fingerprint appears in multiple breach reports. The configuration resembles a relay node you deployed months earlier. You do not panic. Panic causes mistakes. Instead, you begin auditing everything quietly. Servers, domains, its wallet addresses, communication channels. Some systems remain untouched. Others show subtle anomalies, unexpected connection attempts, repeated probes from unknown monitoring networks. Someone is studying the infrastructure. You contact two associates discreetly. One replies briefly and then disappears from the network entirely. His accounts vanish within hours. Another responds with a single message: cleaning up. The phrase carries no emotion, just instruction. You begin dismantling the network slowly, not all at once. Sudden disappearance attracts attention. First, the smaller servers vanish. Temporary relay nodes quietly shut down. Data stores wiped and overwritten. Then the command servers controlling the botnet stop responding. The infected machines eventually reconnect to nothing. The network dissolves gradually. At access marketplaces continue operating without interruption. New sellers appear. New buyers replace old ones. The system does not collapse when individuals disappear. It adjusts. You close encrypted chat accounts that once felt permanent. Years of conversation vanish instantly. Digital identities erased without ceremony. Cryptocurrency wallets are consolidated and moved through several transactions before becoming dormant. Each step reduces traceability. Weeks later, the last infrastructure server shuts down quietly. The screen shows a blank terminal window. No connections, no commands, no systems responding. For the first time in years, nothing inside that network depends on you. You return to ordinary digital life slowly. The internet appears different now. Less mysterious, more mechanical. You understand how fragile many systems remain. But you also understand something else. Every network eventually attracts attention. Every pattern eventually becomes visible, and every operator inside those systems eventually faces the same decision. Continue deeper into a structure that is being mapped, or disappear before the mapping reaches you. You chose disappearance. The system continues operating somewhere beyond your view, but your role inside it has ended.